And so all the things we had to do to make like Hibernate as an example to work on Graal. But don't take it to be specific about Hibernate. It's really more about Quarkus and the technology in general. So I'm Sanne Grinovero. I used to live in Milano for some years, then I moved to London. I'm a bit Dutch. I work in Red Hat for the middleware, research and development group, like Mario and a lot of other people here. And well, I'm more known to lead the Hibernate team, and I'm now also on the Quarkus team because like we all work together, of course, on these things. And well, I'm contributing to several other projects, some my spare time, some just of interest, some of need like Wildfly is integrated with Hibernate, Graal VM. I've been sending some patches now because I needed stuff to be fixed for Quarkus and Hibernate and so on. So I'm going to show you first the highlight, which is like this 5 millisecond demo. And the reason I start with that is really that because that's not really the most interesting thing. And I'm going to show you why that's actually quite ugly. And there are many more really interesting things actually in Quarkus which are built on top of the design that made this possible. So then we will speak a bit about GraalVM and what the internals, how it actually works, and how Quarkus plays with the interacts with Graal and the normal JVM. Like you don't need to use Quarkus just to compile in native. It can be really useful even if you're just building applications for the JVM. And then we'll have some much better demo than the first prototype and explain how this actually works behind the scenes. So what is a native image anyway? It really is like compiling a binary, platform specific. So we're not dealing with bytecode, which then is interpreted or compiled at runtime by a JIT. But we're creating, like, so I'm running Linux on this machine. So if I compile this, I end up with a Linux executable, which can only run on the same architecture. Right? So if you want to then run it on Mac OS or on Windows, you will need to recompile the thing. So essentially, I'm going to try this right now. So we start with that. What you need to do is, for this demo, you have to set your GraalVM home environment, and you just download the GraalVM distribution from graalvm.org. And it looks like as a JDK. It really looks like JDK 8. It just has some additional binaries in there and some additional jars in there which can allow it to do more things. But you can also just use it as a Java 8 distribution. So I use it also to run my Maven, to build my thing, to run my IDE, because it's just Java 8 with some additional things. How do you build a native image? Oh, you have this native image command, which then takes a lot of parameters because you might need to fine tune or give it some extra input, and then you get a binary. So in this case, I'm having a binary which has the same name as my main class, so you see this parameter repeated. Then you have to wait quite a bit because the compilation is extremely in-depth. It does a lot of very interesting things, which we'll talk about later, but it also means that it takes a couple of minutes to actually build this application. Now, the reason is that this binary, at the end, can run on Linux without any other dependency. So you can run it in a Docker machine, and you don't need to install, for example, the JDK. There is no need for that. So let's do this right away. I have this project here, which is really ugly. And that's the point, right? So this was the first prototype. I did this last summer when I got a bit interested. Oh, would it be possible to run Hibernate on Graal? And lots of people were saying, oh, well, no, forget it, because of some of the principles of GraalVM. All our frameworks and our libraries are making some assumptions and have been designed for the JVM in a highly dynamic environment. And we do all kinds of things which are not compatible with GraalVM. I'm going to list. application has been built. So for one reason or another, this is being used by some of the JDK things, so I need to list it. Then, I'm loading the driver. These are internal things of Hibernate that you need to know. These are components from the parser because I'm parsing HSQL in the runtime. So I need those trees to be listed as well. And finally, let me just switch to the end. We are also doing reflection on the entities. So you need to list the entities and their attributes so that they can be accessed reflectively by Hibernate at runtime. This is not really easy to use, right? So we can agree it's quite ugly, but let's see just back to the code. What is it doing? This is starting an entity manager factory by using the standard JPA API, and then it's doing some things with the entity, and you can look here. It's doing several things actually. It's creating a new thing, a new person. It's then query for one person and storing a new one. Don't bother about the details. What I'm doing here is I just show you that it can load some stuff and it can store some stuff, and it's doing those things. Now, there is another piece of complexity here. So person has a relation, and this is a lazy relation. So how is Hibernate normally doing this? Well, it needs to either instrument this class at build time, so you have a Maven plugin to do that, or it's instrumenting it at runtime and needs to load the modified class, or it's going to proxy these things. But none of these operations are legal in GraalVM native images, so you have to do something else. What we do in this case is simple. Like I just take the Maven plugin, which does it at build time. So the classes are enhanced at compilation time by the build. So you might know this plugin. Many people don't use it because Hibernate, if you're not using the plugin, will do it at runtime. But that slows you down here a bit. The runtime will be a bit slower because it needs to do these additional things and load the other classes. And this is actually a better way, but you have to set it up. So that's another annoying thing. In the case of GraalVM, doing these operations of enhancement of the bytecode at build time becomes mandatory because you cannot make changes to the code after it's being compiled. So, and with that, we can just test that this is working. I have another script for that, just to run it. It's actually, it's just invoking the thing. Let me just invoke it first. So it's in the Hibernate ORM protein example. There is a binary here now. It's called example main. See? I can run it, and it's run and finished. It's extremely fast, and it's not taking much memory. So with that, we're done with the title. This can run on 5 milliseconds, especially not on this laptop, on a normal machine. And it connected to the database. It stored an additional person, an additional address. It listed all of them, and it established the connection pool first. So it did quite some work in all this time. And just to show that I'm not cheating, here we have a Postgres instance running in Docker. I shut it down. I start it again, and that's the fastest stack trace error of I couldn't connect immediately. And you get the normal stack trace out of that. Now if I start this again, Docker needs to initialize. Postgres needs to start. Now if I run this is going to fail, I think, because my entity manager is not configured to create a schema. Here this is set to none. I could have set it, create it at runtime. Now, I compiled it before. I'm not going to waste time now to compile it again just to change the options. So there is a schema create binary here, which is nothing else than the same thing that I had before, but with the option flipped. So now it created a schema, and I should be able to run the demo again. So you see, it started it once. It stored one person, then listed them all. So you have one person now. Now I can write again. Now you have two persons and an exception because the schema was already created, so I can't create a schema again. See? Perfect. But this is really ugly. You have to know all the internals of Hibernate, and you have to work around all of these things. And there are many other things that we did not really work around. So if you are trying to use some of the other features that Hibernate has, it would fail, or you have to patch it. Oh, and by the way, this is using a patched version of Hibernate in which I commented out some functions that would never compile to native. So that was, this is to show that it's possible to get an application running on Graal with not too much work, but it's very cumbersome to maintain. And that was honestly a bit disgusting. That's not really giving us the productivity that we're used to as Java developers. As a Java developer, I want to be able to change my entities and move on. I don't have to reconfigure all of my frameworks and know that maybe there is some odd feature somewhere that's not compiling into the native thing. So let's explore how GraalVM is doing and what these limitations are for Graal. So first off, what is GraalVM? So it is a quite large project. There are many components in there. There is a Graal compiler which is able to produce native code, highly optimized from bytecode, and from Java bytecode, but also for Ruby, JavaScript. There is this truffle library which is like a toolkit to create your custom languages, and there are implementations of these well-known languages. I'm not going to talk about truffle in this case because there is no truffle implementation for Java. So Java is the one that's doing this in a slightly different way using the Substrate VM, which is re-implementing those components of the JDK that need to be compiled into native directly. And that's what we're using for Quarkus, and that's what we used in the example we have just seen. So essentially, when we're creating a native image, we are running the GraalVM compiler on your code and combining this with the JDK version, which is the special Substrate VM. And this is combined with your application classes, and you can get a statically executable out of that. And it's very efficient. So it does this static analysis of your code, which means every single line of code that is reachable by the main entry point is being analyzed and converted. This also means that it cannot be changed. Like you cannot add dynamically like we're using in Java, like, oh, let's just proxy something, let's just mock something dynamically, let's load a different thing. There are no class loaders. If you try to get the class loader of the current class, you get null. That's the contract within this machine. Now this allows, though, to do that code elimination very, very aggressively. So if there is a method which is not invoked by some of your code, it's being deleted because what is its purpose? There is no use for this. This is not just methods, it's fields, classes, and entire branches inside methods. So it's extreme aggressive pruning. Imagine something really simple, like you have a logger and you have all these log statements which will print something when you have log traces enabled, but trace is off. So when you compiled it, all those is trace enabled will be removed, and all those messages will be removed, and all the formatting instructions will be totally removed out of the binary. And that's what's making it a bit lighter. Now, of course, maybe you don't want to enable or disable tracing in this way, but that gives you an example. So again, just to recap how you compile to native, you can try this out with hello world, something simpler. It's just native image, you give it your jar, and it outputs a binary. It's pretty easy, very neat. You get an application which is really fast to start, uses very, very minimal amount of memory, and is small on disk, but is native. Right? So let's talk a bit about these limitations. First off, if you go to just GitHub/Oracle/GraalVM, that's where the source code of GraalVM is. It's on GitHub, and it's written in Java. It's totally understandable for Java developers. And there are some really good readmes there which get updated often because these limitations are changing quite often because GraalVM is very actively developed. And we're contributing a bit as well, but most of the work is being done by Oracle engineers at this point. So the thing I mentioned is dynamic class loading, totally banned. You cannot load a class by name because how would it have been compiled if it didn't know that this was an option? So that's gone. This means for servers, like you cannot have a Tomcat or your JBoss server, a Wildfly server in which you upload a war and then this gets started, right? That's impossible. Now, luckily, we are shifting away from this paradigm. Like, okay, microservices, I just want my bootable thing. I'm not going to add a war later. So, maybe, okay, I'm not going to have Tomcat, but I can still run my microservice on this. Now it doesn't have some other things, like JMX is not implemented. You cannot connect with the debugger because this is native code. There isn't your usual JVM running behind it. So, well, okay, no agents. Okay, you have to deal with this code without these things. Okay, you can use GDB. It's a native image. You can get dwarf debugging symbols which help you with GDB, but that's only with the enterprise version of GraalVM. Now that's where Oracle is, having this bit of, commercial, open kind of things. But it's open source. Maybe we get to contribute, well, the things that we don't like to be commercial there. And there are many other things that don't work there, like the security manager, no way. Finalizers, they're off. Invoke dynamic and method handles can't get compiled unless they are very simple ones. Like the one that, if you have a Lambda that's technically, using these things behind the scene, those are the exception that will work. If you have a complex tree of invoke dynamic and method handles, that's not going to work. Reflection. So I said, class by name loading dynamically won't work because how can it know that you might load that class? Well, it can know if you tell it, right? So that's what this JSON file is about. If we can say, okay, I understand you cannot load anything dynamically, but I might need you to load these 20 classes, then those 20 classes, it will just consider those as an option, and it will include the code that is necessary to run those things. Now, also not dynamic proxies, I mentioned that, no resources. There is no class loader, so how do you know how to load a resource from there? It's not going to fold all the resources in there by default, but again, with the flag, you can tell it, can you emulate the resource loading API just for these selected resources because I really need them? So, to help you port something, you can do it, but again, more flags to learn about and more things that you need to do there. Now, JNI, harder, unsafe memory access, needs some specific instructions in there. And then there is this weird thing, static initialization happens in the compiler. We've seen it before. You saw this message being printed out. That's because it's analyzing your code by initializing the classes and intentionally initializing all the static initializers within these classes. And then, it takes a snapshot of those constants. Now, what we do with that? The idea is, we're all used to have like a string constant in Java. We're used to say, make it, public, static, final, use it all capitals and write it on the top. But what's actually happening is, when we read it, it looks like it's just a constant which will be embedded in there. That's not really true, right? What you're saying is, there is a variable there that will be initialized when this class is initialized. And at that point, the string constructor will be invoked with these parameters. Now, okay, that's relatively cheap, but you can have some very complex objects in there which are heavy to initialize, and these are triggered when you're first initializing this class. Now, when this is compiled in native, the benefit is all those initializers will have run at build time, so that then the native binary, when it's starting, is just taking the snapshot of the output of those initialization functions. So it's there already, and there is an additional benefit. Now, if that's a constant in your application, the compiler can use that constant to optimize your code further. And I'm going to show you something really neat about that. But again, so it's doing these operations. It's mean if you have a static initializer function which is run within the static initializer, this is run in the compiler. Now, how odd would it be if in your static initializer you are like opening a file and trying to read it? If your intention was to do this at runtime, then you shouldn't be doing it during the compilation of your application. The same goes for sockets and threads initialization. Now, what happens here is that then the GraalVM compiler is going to verify that while you're running the static initializers, these operations are banned, they are prohibited. If you have a static initializer that opens a socket or a thread or something, you get a compilation error, after the minute wait of the time. Now, this sounds reasonable, but it needs to compile your application and all your dependencies. So if there is just one dependency somewhere in your tree which has a static initializer there, which is saying, oh, I'll just start this timer in background, that's failing your compilation. Right? So you have to patch those libraries as well, all of them. All your dependencies need to be adapted to be compatible with this thing. Now again, there are flags, so you can say defer initialization for this specific final on that thing, so you don't really need to patch all those libraries, but you'll definitely find out about the weird things that are there. So if somebody actually patches those libraries, that's better. And that's what we're doing. Like, we take the libraries that we generally support, and we make sure that they are easy to use on native image. So let's see what's the impact specifically on you just wanting to have a Hibernate application running in GraalVM. Not from the point of view of the hello world I showed before, which is storing one entity, doing a query, running two operations, but from the point of view of all the features. Like, would they be able to port like a complex big Java application which is used to use all kind of features to GraalVM? Well, let's have a look at what I have here. Mind map. Let me zoom back a bit. Oh, actually, that's fine. So we said no resource loading. Well, Hibernate allows you to import a script at initialization. So what we do is, well, we automatically register such an import script within. So essentially, we are calling into the GraalVM SDK, which has an API for the compiler, so you can give it a hint like, okay, so this application has been configured to import a SQL. So I will need that SQL, so I'm going to register this for reflection, to be loaded as a resource, right? It's easy, but it's automated, okay? Now, another problem is the broken class path. We are used to have, especially in Maven world, you might have a dependency which is optional. That's not allowed either, because if your code is saying, well, I might load this class, but I'm not actually doing it because it's just one of these branches of the if, so we are fine if you are not having it and you're not entering this if. That's not okay, because the compiler needs to be able to compile all your branches and needs to be able to know what code is going to generate in case you enter that branch, unless you prove that that branch is totally off. Switching back a second. So how do you disable a feature? So we said JMX is off the table. It doesn't work in GraalVM because literally the methods which are registering the J management beans in Substrate, they're not implemented yet. It's all work in progress. Maybe they don't plan to implement them. Maybe there is some problem with implementing them, or maybe we just think management beans don't fit in this world. So Hibernate has an option to register its own statistics with the management bean so that then you can connect them and then read them. But this is a flag, right? So if I were to say, well, just disable it in your configuration file like this is not going to compile either, because you need to persuade the compiler that that flag will never be enabled. Otherwise, what if he enables it? I haven't compiled for that. I can't adjust for that later. So this is how a feature needs to be disabled. It needs to be a constant in the code, baked in there. So how do you adjust your code to make sure that configuration changes, that you can still configure them, but they are actually seen by the compiler? Well, we have to interact with the compiler, or what we're doing with Quarkus is we're literally generating your bootstrap bytecode, which looks like this. They are constants. So at this point, it's more interesting. So GraalVM will look at this code saying, okay, well, this was configured with management beans disabled. This is definitely disabled. It's always going to be disabled. So I'm going to remove this code, and I'm going to remove all the code in the Hibernate libraries which has any capabilities related with management beans, and you're saving more space, right? And it's getting lighter, and it's getting faster. Back to the mind map. So yeah, broken class paths are a problem because lots of dependencies in Maven, they will depend on something. Maybe if it's there, I will try to load it. If it's not, so to compile it, you will need to have all the optional dependencies there or make sure that they are really disabled. So for JMX, you have seen it, it's off. The security manager, it's off. Like these features are not available if you're compiling in Substrate. Background threads, well, that was a problem. There are several libraries that we use that actually I never knew about this, right? But then you're compiling it, and then it's like, huh? Who's starting this thread over there? Why are you doing that? And then you just figure out that every time we started Hibernate in years, there have been other libraries which were triggered its initialization, and we never knew about that, and they were spawning additional threads just for features that maybe you weren't even using. And I have a very nice example about that. We'll see that in action actually. So reflection, how does it impact Hibernate specifically? Do we need reflection? Well, this is actually like a, what do you call it, like a legend. We actually don't use that much reflection in Hibernate because there are, so it can use reflection, but it's just one of the many strategies that we use to create classes or do the dirty checking or verify the things. So the only thing needed here is just let's use one of the other strategies, but make sure it's not one that uses enhancement at runtime, proxying at runtime, or so on. I'll switch quickly to this side. So no runtime bytecode enhancement. What we do is we do it at build time. So those static initializers, things that you have seen, during the initialization, when the Graal compiler is running, it's compiling entities which have already been enhanced by any needs that the compiler will need. So it will just see the additional elements that then Hibernate needs to use these. And well, we talked about the constants. Let me say one more thing about constants. So in Hibernate, when doing this prototype, I was focusing on PostgreSQL, and there were many weird things done for Oracle in the Hibernate code base, which for me were in the way. Like, let me just comment it out. Like, let me remove Oracle support, but then I get in the broken class path problem. So I couldn't just comment out some code depending on it. I had to start removing all these things. Then, well, by doing this work, I realized at some point, I was refactoring, remove this, remove that, I don't need this, remove that. I got to 280 classes removed, and then I gave up. There were more. So it was like, okay, this is not the approach. Now, the interesting thing is the way we do stuff now with Quarkus is if your application is compiled to target Postgres, we know that this is generated as a constant. And the whole build time is enhanced in such a way that then the Graal compiler is able to do the work and remove all that stuff that's not related with connecting to Postgres. Like, why do you need to have all that code that's connecting with 25 different versions of Oracle, 30 different versions of DB2, and all those other things? So let's get rid of it. And this is controlled simply by your configuration line of setting which database you're targeting. The fact that these have become constants is what's optimizing the whole thing. So the same goes for proxies, class loading, and let's talk about class path scanning. So as you know, you initialize Hibernate, and then it needs to search for which are the entities. So let's define the model and the metadata of the model. So it needs to scan your class path to find all the entities which have the annotation at entity or at map at superclass or all the various things that it might relate to. Now, that's requiring you to access the annotations and the metadata of the classes. I don't want to do this at runtime because it pulls in all this extra code that we need to run. And why should you do it at runtime? This is a build time step. When you're assembling your application, you have maybe 200 entities there. We scan them, and we create a list. This list is a constant, and the constant gets folded into the bytecode again, and then we can optimize based on that. So again, if your model is not using any like UUID ID generation strategy, which is one of the options that Hibernate has, that code can go when it gets removed. So you're getting a very fine-grained modularity in which everything that is not really being used is removed out of the binary. Now, another benefit is when we do this class path scanning, we actually use Yandex, which is a library which looks at just stream bytecode very efficiently, looks only for the annotations we need, and it's not initializing the classes. Since you're building, we don't want to run all those initializers, which are very slow, and you're wasting time with that. Let's go on this one, which is a favorite of mine. So like a year ago, we were trying to figure out, like we had some bug reports about people saying, oh, I have this complex application. Okay, it's rather complex. It has 1,000 entities and a ton of beans, but it's taking 8 minutes to boot. Can you have a look to what is it doing? And so I think it was the first time among a year ago that we actually started to look at how can I, what's going on when Hibernate boots. What is it doing with all these things? We always optimized for, I want it to be fast and efficient after it's booted, right? I don't care about boot time. But when it gets to like the minutes, then you're starting to worry, something is wrong there. Let me have a look. Now, having actually such a large model gives you more data. So one thing I figured out after resolving the 8 minutes down to like 20 seconds, the next step was that when you're starting it, the first thing we do is we need to parse the configuration file. The configuration file is an XML format. So you're initializing the XML parsers. Fine, that's logic, right? And then you parse this configuration file, you read the properties and you start doing the boot. But now if you're doing this within the JVM, you initialize the XML parser, and if you look at, I think it was Xerxes in this case, when you're initializing it once, all the static initializers, Xerxes is full of highly performant optimizations internally, which is like constants. It's defining a lot of constants as singletons in there. So after they've initialized it once, they're taking memory forever. And in my case, I was just reading configuration file, a boot, and then never use it again. I measured it. That's about 20 megabytes of heap space gone, plus all the metadata of the. So if I'm actually parsing the configuration files during the build of the application, I can also avoid initializing all the tools that you need to actually start the application when it's starting. I already have all the metadata. I know which entities they are. I know which generation strategies, which caching, which transaction manager. All the things that I'm going to need have already been defined. And that makes it a smaller circle, a much smaller set of things that need to be actually initialized when the application is starting. The benefit of that is that it starts way faster in JVM mode. And that's why really you can start the same application in JVM mode and it will take 200 megabytes of memory, and then you parse it with the Quarkus application and it will take 60 megabytes of memory. And it's doing the same things and it has no drawbacks. So this is the point in time in which we realized that some of the drawbacks of GraalVM's native image were actually making us think better of what exactly needs to happen in terms of defining the application and booting it in a very efficient way. Let's get back to this one. So what is Quarkus? I need to speed up a bit. It's a toolkit and framework that helps you to do all this stuff that we have just seen, but it's also like a collaboration with all of these frameworks so that they can restructure their internal code to be lighter to run and be able to infer all the metadata that you need at build time so that then it can also be built as a native. But that's just one of the targets. Oh, and Kotlin. So how it works? Well, you have your applications, and then we have a build tool which is based on either Maven or Gradle, like the two parallel sets of plugins, and they will create an optimized version of jar. We call this an augmentation phase. And then this jar can be either run on a normal JVM as usual, or it can be compiled to native, and they are going to be semantically the same, unless you are breaking some of the rules of this stuff will not work in GraalVM. But we should not do that, right? So our framework should behave the same in both of those. Now, the great thing is it's not about Hibernate only here. We imported a lot of technologies in the prototype. Like after prototype was kind of successful, we started saying, okay, now I will need, well, Undertow is actually being explored by Stuart in parallel with Hibernate. So we are exchanging ideas. And then we have a ton of technologies which are now able to infer this metadata, not when your server is starting or your application is starting and suddenly it's like, hey, what are my CDI beans? What do I need to do? Like, no, you already know that. At build time, they're all there. Because it's a closed world, it's a microservice, you're not deploying things, right? So for example, we have these CDI-based annotations based on a new container. It's not using Weld, it's a rewrite from the same Weld team. Focused on these neo-design paradigms, right? So we want to infer metadata at build and use it later. We have, Vertex, Hibernate, REST-easy, Camel, Netty, Kubernetes, Jaeger, lots of things coming, and many more are coming. It's not enforcing you to be imperative or reactive. Like we have people who love both. So, okay, you can choose both. This is not feature parity today. Like you cannot really do everything at this point in reactive because it's work in progress, right? It's not the final framework, but we aim to do that. And what's this developer joy story? So first off, we hope this is really easy because in terms of your code, it's the same JPA entities, it's the same CDI annotations, it's the same frameworks that you already know how to use. So you could, I don't think that you can easily take your war, run it in an automated process and port it, but it should be easy to program, like very familiar. It's the same concepts. And we have live reloading. So the fact that this metadata can be built before and the actual code in the JVM is really light and there is no dynamic or chained or modular class loaders going on, it means that we can control the basic class loader for development mode and have a really quick interaction. I need to skip some things if I hope to show you the better demo still. So the focus is really on, this is focusing on clouds and containers, right? It's great that you can run smaller things and that they can spin up really fast and they don't take as much memory. Like there isn't this huge overhead just because you start at a big server. Let's show this. I have 10 minutes, a bit less. So this is my demo number 2. How does it look like? So Quarkus, this is a Maven version. I'm using the extensions for ORM, Graal, the connection pool, REST-easy, REST-easy JSON, and the MariaDB driver. So this is similar to one of the quick starts out there, just that I switched it to MariaDB for an interesting reason. There is an import SQL, and there is just 2 classes and an application properties, which is the configuration file. So configuration file will look familiar, like it's new, but I need a connection to database, how to connect, let's generate this thing, and yeah, let's log some SQL. I have one entity here, the fruits, and I'm just toying with some features. So I have like a named query, I make it cacheable, import it to cache as well, and 2 attributes, that's it. Hibernate doesn't really need the getters, but the other frameworks here are using them. Then we have an endpoint, which is injecting an entity manager. So all of this stuff will look really familiar, and it's using the standard annotations. So it's just injection, it's just JPA, and you just run the query as usual, except that everything here is analyzed at build time. And to do the analysis, we haven't really run like a new project which does the analysis. It's booting the actual framework. So there is no mismatch or like something that worked in this is not working in the other. And we have some operations. Ready? Now, so this is the table I have in MariaDB now. I can try to curl my endpoint, and there is no endpoint, so because it's not started. Yeah? So let me show you just the dev mode. I start it. As I said, this is a very slow laptop, and I have a ton of demos ready, so bear with me. It's a very slow time. But now we should be able to curl this endpoint, And okay, so this is the one that gives me the list here, and it's listing all my fruits, the ones that are in this database and my import SQL. So what happens now if I want to add, I don't know, a mango? I just have to edit this file and save it, and I do a next one, fruits. You see, in that terminal, it rebooted, and here I already have, it imported my new statement in the database because it rebooted everything in background after having compiled, augmented, and analyzed the process. Now, this is the schema again, but let's change the schema. Do we want to add something in here? Let's say a new column. Oops. So if I have a new column there and I get for those, oops, I did something wrong. I didn't import date. Why is it not auto-suggesting that? Was that the problem? Yeah, date. Oops. Sure. Thank you. I'm not sure why it's not suggesting anything. I think if the power save mode or... Yeah, that's better. So now I got these things back. Well, there are no dates, but let's check the schema. It's not there either. What am I doing wrong? Open create. I'm confused. Sorry. Is it not using that? Huh? Oh, it's not. It didn't compile. That's also why I didn't get the notification here. Well, no, that's not true. Nope. Sorry, I don't know what's that, and I'm running out of time. Huh? Oh yeah, right. I needed the getters. But okay, let's do something different. So there is a unique key there on name. Let's just remove that. It's maybe easier. Yeah, you see, the unique key on the database is gone now. That's because it's like regenerating the schema on the fly just from changes in the entities. Sorry, I got confused there. So that's developer mode. Now we can compile this to native, but we're running out of time, so you'll have to trust me. That would work, but I'm going to intentionally break it so that you see something interesting. So what I did, let me just start a compilation because it takes some time. So this is how you compile to native an application with Quarkus. What I did now is I removed from the dependencies, I removed our extension for the JDBC MariaDB driver, and I'm just using the driver itself. So I'm not using the Quarkus enhanced version of the driver, which knows how to deal with MariaDB, but we're just taking the driver, which I know is broken, so this is going to fail. Who can guess how this is going to fail? Unless you tried it, there's no way you get it. But. So it's compiling here. It's doing its augmentation, which means that during the compilation, this is really interesting. This is the GraalVM compiler running the native image tool, but you can see it's logging. It initialized Hibernate ORM. The commons annotations, there is a transaction manager being started, and the XNIO, all the systems that you need in a server, they are being started within the native image compiler so that they create the metadata and create all those nice constants that we want to then optimize everything to the extreme. Didn't fail yet because my laptop is really slow. Maybe I should go on with the presentation because we're running really slow. So how does it work? I already mentioned most of this. Let me just skip to the interesting thing. So yeah, we do all the configuration parsing and the building of the metadata, inferring all the interesting metadata upfront during the build time. This is written as bytecode, which is then included in your application, taken by the GraalVM native compiler, and that's then constants and metadata which is useful to actually run it. This can be done as like static initializers, mains. There are a ton of frameworks already there, but we can where I want to say. So most of these extensions are separating the runtime from the build time strictly. So you'll have a runtime dependency for Hibernate and the deployment dependency of Hibernate, which is what generates this metadata. When we're actually packaging the application for the runtime, those additional dependencies which were only necessary to deploy, they're not included. That's also what's making the JVM mode much lighter. Okay, it failed. And the error you have is I couldn't initialize the OpenGL renderer because, of course, SQL needs that. And I'm running out of time. The reason MySQL generates this error is that one of its way of possibly authenticating to the database, one of its options is to show you a dialog box. So to show you the dialog box, it needs to initialize JavaFX, which initializes a background thread to draw the icons on your desktop and things like that. This is happening every time you are connecting to MariaDB, and it's just an example, right? And we are bypassing all that kind of stuff because it's disabled. Let me just switch to the conclusions. So last note is it's not 1.0 final. We're working a lot on it. Many more extensions are being added. Performance is improving a lot. And you're very welcome to join. It's an open source project. It's Apache licensed. It's on GitHub. If you need some other extensions which aren't there yet, you can, if you don't feel comfortable, maybe we can help trying. If you feel comfortable, I can teach you how to create them. And thank you very much. If there are questions. Thank you.